Welcome to this video, dear learners. We are going to be discussing on acceleration due to gravity. So we looked at acceleration, velocity and time, and we looked at the three equations under uniformly accelerated motion. If you haven't watched these two videos, before watching this video, you can start by watching the videos on linear motion on the same channel. And if you're new to the channel, please hit the subscribe button, like, share and comment on the video. So acceleration due to gravity. Okay, so we're just looking at acceleration that is as a result of gravity. Okay, so gravity affects acceleration. Okay, so we know that here on the earth, okay, here on the earth we have what we call gravity, and gravity simply, if we can explain gravity, okay, if we can explain gravity, we would say that gravity is simply a force that pulls objects down. Okay, you can say this is a force that pulls, okay, a force that pulls objects downwards. Okay, so if you were to jump, okay, if you were to jump up, you'll find that all of a sudden there'll be a force that will pull you downwards. Okay, so this is the force that pulls all objects, okay, downwards. Okay, if you throw something up, it will still come back down. Okay, why do things come back down once we throw them up? This is because of what? This force we call gravity. So gravity is a force, okay, and this force pulls objects downwards. Okay, so let us say you're here, you throw a stone up. Okay, so you throw a stone up. This is your stone. Find that once you throw the stone up, it will come back down. Okay, so now what has happened here is this: when throwing this stone up, you applied force. Okay, you applied force when throwing it up, but for it to come down, this is not because of your force that you applied. Okay, the force that will pull this stone, okay, the force that will pull this stone down is not the force that you applied it with up. Okay, that's why I find that you can throw something with a high speed, but the rate at which it comes down is constant. Okay, so the downward force, okay, the downward force here is what we call gravity. Okay, the downward force is what we are calling gravity. Okay, the downward force is what we call gravity. Okay, so this force here, that will make the stone to come down. Okay, and the motion of it coming down is called a free fall motion. Okay, it is called a free fall motion. Okay, so free fall motion, this is a type of motion that objects will experience when gravity is the only force acting. Okay, so for all free motion, you should always know that gravity is the only, okay, gravity is the only force acting. Okay, gravity is the only what? Force that is what? That is acting. Okay, So now let's look at what the gravity on Earth. Okay, the gravity on Earth. Okay, so gravity on Earth is simply equal to 10, okay, meters per second squared. That is the gravity on the Earth. Okay, 10 meters per second squared. Okay, 10 meters per second what squared. That's the gravity on the Earth. So other units could be 10 newtons per kg. Okay, but usually when we talk of acceleration due to gravity, okay, acceleration due to gravity. So let's look at some more illustrations on this. Okay, so acceleration, we talked about acceleration. Okay, it's a change in velocity with time. So now we're going to say acceleration, okay, acceleration, which is denoted by the small letter a, okay, acceleration, okay, is equal to gravity. Okay, acceleration is equal to gravity, okay, for a free fall motion. Okay, for any free fall motion, your acceleration will be equal to gravity. So in other words, acceleration will be equal to gravity, which is equal to 10 meters per second squared. Okay, acceleration is equal to gravity, okay, for a free fall motion. Okay, so let's look at this scenario here. Okay, so now we're going to look at this scenario. You have a human being here. Okay, and then he throws a stone. Okay, this is a stone, then it comes down. Okay, okay, so he throws a stone up and then the stone will come down. Okay, so here this is throwing up, but this side it is free fall, meaning it's falling freely. Okay, so what happens when it's going up here, it will reach this point where it stops momentarily. Okay, though you might not notice it, but it actually stops for some few seconds before it starts to fall down. So what is acting here, the force is called gravity, and this gravity is the same as your acceleration, which will be 10 meters per second what squared. Okay, 10 meters per second squared. Okay, so now once you throw this, okay, if you throw up a stone, the stone here, this this side, okay, let me explain what is going on this side first. So what is going on here when you throw it up? Okay, when you're throwing up, when you're throwing the stone up, what is happening here? So you notice that going up, the stone is going up like this. The stone is going up, meaning it is acting against gravity. Okay, it is acting against gravity, acting against gravity. Okay, it's acting against gravity here. Okay, when it's going up, okay, it is acting against gravity. So if it's acting against gravity, meaning that your acceleration, which is equal to gravity here, is going to be negative 10 meters per second squared. So that's one thing to take note. When it's going up, okay, your gravity, which is your acceleration, is going to be negative 10 meters per second. Okay, but for free fall, okay, For a free fall where it's coming down, okay, here now it's coming down, okay, for free fall, for a free fall motion, it is coming down, so it is acting towards gravity, not against, okay, it's towards gravity. So meaning your acceleration due to gravity will be positive. So the take-home message here, when it's being thrown up, okay, when it's being thrown up, you should know that it's acting against gravity, so it will be negative. So when acceleration is negative, we call this deceleration, okay, we call this deceleration. And when it's going up, we call this acceleration. I mean, when it's coming down, okay. So downwards is acceleration, going up it's deceleration, because here it is now positive, positive acceleration, okay. So the same thing will happen if, let's say, you're a human being here, you're standing on a certain height, okay, on a certain height like this, okay. Once you release a stone, it starts to come down, okay. All this we call it free fall, okay, free fall. And for any free fall, acceleration is equal to gravity, which is equal to 10 meters per second squared, okay, for any free fall, okay. So now here we are assuming that air resistance is what is ignored, assuming that air resistance is being ignored, okay. So for all this, we are assuming that air resistance is being ignored, okay. Let's have a look at an example, okay. So we have a question here as an example. A body falls freely from rest, okay. Air resistance is ignored, gravity is equal to 10 meters per second. We have questions: what is its velocity after 1 second? How far does it reach after 1 second? Okay, so here, how far? Always you see how far, okay, how far, okay. You're being told how far. Here they want you to find the distance, okay. So let's have our solution. So for physics, I like to visualize. So they are saying a body falls freely from rest, so it's falling, okay, meaning it's, let's say it was at a certain height, okay, h, the height, so it's falling, coming down, okay, till it reaches here, okay. I like to visualize, okay. So it's falling, coming down, okay. We are told that the time that it will take 1 second, 1 second, okay. So now we should told to take gravity, okay. So we're going to say from our data, time is 1 second, okay. Time is 1 second. What is its velocity, okay? Velocity, that's the final velocity we don't have. What is the initial velocity? So remember what I said, okay. Whenever you see this, okay, something starting from rest, okay, starting from rest, always know that initial velocity is 0, okay. Initial velocity is 0. When you see the words a body falls freely from rest, or a car starts moving from rest, okay, so just know that your initial velocity is 0, okay. So initial velocity is simply 0 meters per second, okay. So now what we want to find is the final velocity, okay. So the final velocity, so the formula for finding the final velocity, okay, so for A we are going to say final velocity is equals to u plus at, okay. But okay, we are told So this is a free fall. Okay, this is a free fall. Okay, and the question has stated itself, falls freely. Okay, so this is a free fall. So for any motion that is free fall, means that your acceleration is the same as your gravity, which is 10 meters per second. Okay, so our acceleration is simply 10 meters per second squared. Okay, now that we have everything, we can solve the question. Initial velocity, that is 0 meters per second, plus acceleration, that is 10 meters per second squared, times the time, that is 1 second. This will give you 0. 10 times 1, it's simply 10. Okay, so you have 10 meters per second, and this is your final velocity after 1 second. This is the final velocity. So that is for question A. Then question B, how far does it reach? Okay, how far does it reach? You want to find the distance. So how far does it reach at 1 second? When distance we want to find is the x here. Okay, so this whole height is the distance. Okay, and we know the formula, x is equal to ut plus half at squared. Okay, so this is going to be 0 times t is 1 plus half times 10 times 1 squared. This will give us 0. 2 there, 1, 2 into 10, that is 5. So that is 5 times 1 squared, that is 1. So the distance is simply 5 meters. Okay, the distance is simply 5 meters. Okay, the distance here is 5 meters. Okay, so this is what we have for this question. We have another formula though for calculating distance, which can be x is equal to v squared minus u squared over 2a. You can also try to use this one, and you definitely get the same answer. Okay, definitely get the same answer. Okay, so now that we have looked at this question, I hope you've been able to learn something from free fall motion. Okay, might pause the video, rewatch the video as much as you can until you understand. So just to have a quick recap, we've looked at acceleration due to gravity. We defined what gravity is, a force that pulls objects downwards, and we've discussed what we call free fall motion. Okay, we discussed how gravity is equal to acceleration for a free fall motion. That's how we learned. We went to do an example. Okay, I hope you find this video helpful. If you do find this video helpful, please click the like button, subscribe to the channel, share it amongst your friends,